All right. Good morning, good afternoon, good evening, or depending on your time and your location. I'm Engineer Moses Unafe. Previously, we discussed on Atex electric motor phenomenon and MCB calculation rating, calculation of contactor rating, overload rating, and also substarter rating and variable frequency drive application to motor. And today, I encourage viewers to watch the previous video for better understanding of this topic. Today, we are going to discuss on same Atex electric motor design and installation, but our major focus is going to be on Atex electric motor shaft monitor. And before we can continue with that topic, I want us to understand some basic things on electric motor. As you all know, an electric motor is an electromechanical device that converts electric energy into mechanical energy through the interaction of magnetic field. And these two main components that enable this conversion is the stator, which is the stationary part, and the rotor, which is the rotating part. I want you to understand that the rotor is a rotating part of a motor located inside a stator, and a magnetic field generates by the stator to produce a torque. And how is it constructed? The construction is based on the core laminated with iron core mounted on a central shaft. Then the conductor part it can be one of the two types depending on the motor design. Then when we talk about the casing, it's an aluminum or a copper bar short-circuited by end rings, which is commonly induction motor. Then the winding rotor is a copper winding connected to external resistor via a slip ring, which is used for speed control. What is the function of this rotor? It functions as electromagnetic induction. That is to say, when a stator or rotor magnetic field cut through the rotor bar, an electromotive force, which is regarded as EMF, is induced in the rotor conductor. It also functions as a current flow in torque production. The induced EMF drives a current through the rotor conductor. That is to say, according to the principle, the rotor develops a magnetic field that opposes the stator field, creating rotational torque. It also functions as mechanical output. That is to say, the rotor shaft transfers the torque to external mechanical load, which is used as pumps, fan, and conveyor. And another function is a working principle, that is, interaction between stator and rotor. The working principle of the stator and the rotor interaction depend on the type of the motor, either an AC or a DC. But the fundamental concept is electromagnetic induction. We can't stop without talking about the stator. The stator is the stationary component of an electric motor that generates a rotating magnetic field when energized with electric current. And how is it constructed? The core. The core is made up of laminated silicon steel sheets to reduce the eddy current loss. Then how about the winding? The winding coil is a copper or aluminum conductor, one in a slot with stator core. These windings are connected to power supply, either AC or DC. Then talking about the frame, which is regarded as a housing, it provides a mechanical support and help to dissipate heat and external impact. How does this function? It actually functions to generate a magnetic field. That is to say, when an electric current flows through the stator winding, it creates a magnetic field, which is regarded as DC motor, or a rotating magnetic field, which is assumed as a AC motor. Then it also functions as induced current in the rotor. Induced current in the rotor. That is to say, the stator magnetic field cut across the rotor conductor, inducing the current through electromagnetic induction. And also function as providing a mechanical support. That is to say, the stator serves as a solid heat dissipating structure to hold the rotor in a proper alignment. I want you to understand that in Atex electric motor, for we to get a full understanding of it, the Atex electric motor shaft monitor is an advanced technique used to accurately determine the mechanical power or delivery by the motor to its load, instead of measuring the total input power, which include a variable motor losses. This method is isolate the actual shaft power by subtracting the calculating the motor losses from the total motor power. Then the main idea about it is that the shaft power is reflected through a load applied by the application, not the motor internal losses. It calculates using the unique principle and typical display on the motor nameplate in either horsepower or kilowatts hour. I want you to understand that the system supports both direct and indirect control via standard and relay outputs. As you can see on the slide, if you look at the diagram here, you will see a typical three-phase motor that is connected to this, that is connected to the shaft monitor. The L1, L2, L3 are connected to the phase, while the S1, which is the current transformer input, and the S2, which is the current transformer input also, then then we have the R1, which is R2, which is the main alarm relay and the pre-alarm relay setting. I want you to understand that all these settings are imputed to ensure a successful programming of the shaft monitor by looking at the reset key, the auto set, the next key, and the enter key for imputing. And for us to continue this, we have to follow a start window. In this start window is coded with 00 to mean that alarm indicator 01 is a major shaft, then 02 is a major line voltage, 03 is a major current, 04 is a monitor functions. Then 13, 14 is the minimum pre-alarm and the main alarm margin, that is for overload and underload. Then when we talk about the code of window 32, 33, and 34, is a response delay maximum, which is a response delay setting. Then 35 and 36 is the pause and reset mode. Then when we are to impute a programming on the rated current, the rated motor power, and etc., we have to use the window 42 and 41 in setting the shafts. And by so doing, window 43, which is the number of the phases, will also be imputed to indicate the numbers of phase of that very particular motor. Now, let's take, for instance, that a motor is supplied to a site, which a motor rating at the nameplate is 2.2 kilowatts. For us to program this, let's follow the step below. Now, the programming is that we have to go to the window 41 by imputing the 41 to impute the rating of 2.2 kilowatts. Then we press either minus or plus to set the motor power indicator from the motor nameplate. So remember that the motor nameplate is to give you the rating of that motor. Then press enter to confirm the change. Then go to the window 42 to set the rated current, which is 5.6. Remember that you have to press minus and plus to set the motor current indicator to motor nameplate. And also press enter to confirm the change. And I want you to understand that in the previous video on the drawing we saw on that very particular shaft monitor, it indicated that we have a connection of stop and start. Now, it is recommended that 6 and 7, terminal 6 and 7 be bypassed during the programming if a stop-start is connected to the circuit and restore immediately after process. This is to ensure effective programming of your shaft monitor to protect your Atex electric motor safely. I want you to share this video so that others can as well gain knowledge. Thank you.